Swayam Prabha. Digital India. Educated India.
Hello everyone. In this lecture we will discuss about sustainable building materials. So as you know, this is one of the most important chapters, one of the most important lectures, and important why? Because the building materials actually constitute a major portion of the sustainability impact, because material in itself actually forms the largest bulk among everything, and it requires a lot of resources, it requires a lot of energy, and it creates an impact during its lifetime, at the beginning of the stages of its lifetime, in even after at the end of its lifetime life cycle. So let's see what are the tentative selection criterias. Okay, so those are obviously the aesthetic quality is one of the important ones, but apart from that we are looking for here a durability, ecological impact, embodied energy, performance, social impact, cost, non-toxic or whether a less toxic material, or a renewable energy. We are looking for a biodegradability. So these are the terms, these are the criterias which have become very important, very crucial in the in the sustainability studies, and why that we have discussed separately why they are important. So we will discuss more from the perspective of materials over here. So the fundamental principles which are can be used, we can call them even strategies also, through which we can devise our guidelines, devise, we can design accordingly, and we can fulfill the requirements. So those could be a structural design efficiency. Why structural design efficiency is important? In order to reduce the wastage of material, because usually in the lack of the knowledge, we may end up spending more where it is not needed, or maybe we can end up even with the little material where it is needed. So a thorough and analytical study is needed to analyze the structure before going for the construction of it. So in order to optimize the efficiency of the resources, optimize the efficiency of the materials used in that. So structural design efficiency is one of the very important ones as far as the building construction is concerned. Then comes the energy efficiency. Well, of course, buildings consume energy throughout their life, and mainly during the their operation stage, the consumption of energy goes very high. So we must go for energy efficiency also. Water efficiency, well, water is available in the finite quantity. So as a natural element, this is one of the most scarce elements, scarce resources in today's times, in the recent years. And we are seeing what are the kind of crises which are happening in the in the non availability of water in the summer months, and those other typical months. And material efficiency, of course, we can save on the bulk, we can save on the manufacturing processes, we can save on the resources itself. So there are several advantages for saving on the materials. And of course, waste and toxic reduction. So see how the rating method of GRIHA, Green Rating for Integrated Habitat Assessment, recommends sustainable building materials a criteria in their GRIHA framework. So the latest GRIHA framework version 2019 has three criterion. You can see over here criteria number 19, 20 and 21, which talk specifically with the a material sustainability factors. So the first one is utilization of alternative materials in the building. So what it means over here, we should look for alternative materials, alternative sustainable materials for the other regular materials which are energy intensive, which are material intensive, which are which could be toxic in the nature. So it talks about you going ahead for the alternative of the those sorts of materials, and it gives a good weightage of 5 points over here in its a framework. The second criteria which comes over here is the about a reduction in the greenhouse gas emissions parameters through life cycle assessment. So it emphasizes on the analysis it is emphasizes on the environmental impact assessments. Okay, it in emphasizes on the evaluation before going for the execution of the project. So this is one of the very important points over here that we have studied in the life cycle analysis and EIA actually lecture, that we have to be very cautious about the evaluation of the building at the design step only before going for the final execution of it. The last one topic actually talks about here about alternative materials for external site development. So that has actually got 2 points dedicated for this one. So this also talks about about the alternative materials for outside the building on the site requirements. For example, creating a boundary walls, or maybe creating for a pavers, creating a landscape, creating other elements on the site. So those also can be used for with the a locally available material, which can be a alternative to the a manufactured or fabricated material from the factories. So here if you see the focus is on saving on the the impacts. Okay, saving on the other conventional material which are having some sort of impact on the ecology. So this is the actually purpose of going for the sustainable building materials in the construction. So how these alternatives can be actually evolved. So this is a list of actually those alternative materials which can be actually used as a main resource material, but they are actually a byproduct. They are actually waste of some other actually product. So we can see we are all familiar of this fly ash material, red mud, slag, unfired clay bricks, and manufactured sand, glass, and there are several other actually list of materials which can be used as, and these are actually being adopted in the recent times in the construction industry as a alternative material. Here if you see in this slide, it talks about using mainly the materials which are still available in their a natural form, natural a condition, and which are we can say they are not so highly or complex processed. So they can be actually taken care of while dismantling, while actually disintegrating, while actually disposing them at the end of their life cycle. So those could be like a paper, those could be artificial stones, carbon fibers, translucent concrete, rubber modified asphalt, plastic, recycled bitumen, silica fumes. There are several other types of material, even a husk also of a several crops, and cloth rayons, and fibers available from discarded actually garments. So these could actually find several applications of it in the whole construction actually material category when we are talking about. Well, how these can be used? So this is one actually very interesting example from India itself. Here we can see this road actually was constructed. The top layer of it, this road was actually constructed using the actually waste plastic, and you can see the hoarding over here which talks about the plastic waste road. So there are actually several advantages. This plastic is going to land up in the a landfill. So how this can be put to use somewhere? So we spoke what is the pollution? Pollution is the actually a wrong place. Material, when a material actually reaches at the wrong place, it becomes a polluting actually thing for the that place obviously. So why can't this material which is a pollution for the rest of the environment can be put to some use? So it has a use a higher percentage of a plastic waste. It reduces the need for a bitumen by around 10%, increase the strength and performance of the road, reduces the cost to around 5,000 per kilometer of a single lane road, generate jobs for rag pickers, develop a technology which is eco-friendly, improvement in fatigue life of road, and better resistance towards the rainwater and cold weather, also better resistance towards rainwater and cold weather, cold situations. So these are actually some advantages we can have over using a conventional a bitumen based or tar based actually road surfaces. So why not to have such experiments, and we can evolve actually methods and ways to have such constructions in other places also. This is one example you can see over here. This is a building in Milan which actually sucks the pollution content part from the air from the atmosphere, and this is known as like a smog eating actually machine smog eating actually building. So we will look at the details of this building. If you see, so the cladding of the white sinus building in both highly innovative and like a sustainable. The 9,000 square meter facade was realized with 900 biodynamic concrete panels developed by Ital Cementi. Its TX active technology captures air pollution when the envelope material comes into contact with light, which it then transforms into inert actually salts, reducing smog levels in the environment. Each exterior panel of Palazzo Italia, produced with the StyleComp technology, is unique, and the building itself is like a net zero energy building, which means thanks to the design team's extensive use of photovoltaic glass and photocatalytic concrete cladding, the structure is capable of covering its energy needs autonomously. So you can see like how interestingly, how innovatively the technology is used over here. First of all, to go for the net energy building concept, and second, to reduce the pollution from the air of the atmosphere. So this is one of the beautiful examples which I came across to share with you guys, like how we can put to use like a several interesting innovative exercise, innovative like materials, innovative like techniques, innovative like processes to improve all the overall like a sustainability factor. If you see over here, the major three resources which are required for like any building construction is the materials, of course, energy, and the water. So these are the three actually major resources which we need, and our sustainable building design approach has to consider these three resources in terms of their depletion and the environmental and social impacts associated with their use. So we have to take care of these because all of these three are very crucial, and all of these three, like if you see the volume of it, so they were being the related from the buildings being related from the built environment, which consumes the largest actually energy from among all the sectors across the world. Okay, so this is one of the actually highly potent areas where any sort of intervention is welcome to save either of these three important resources of materials, energy, and water. So what are the environmental impacts of material use? If you see, during the past 30 years, an increased understanding of materials and their characteristics have brought to light other less obvious impacts associated with materials, which affect people and environments well beyond the building envelope. So the potential remoteness of the impacts of the material use makes the link between the cause and the effect. So when we talk about how such big impacts actually coming in the recent times, well, there is this cause and effect actually method in place which is working to create actually imbalances. So by the human intervention, by the human misadventures in the ecology, to destroy actually forest, to destroy actually the pure state of water streams, rivers, lakes, and pollute the airs. So these are all occurring into other catastrophic events such as acid rains, increased temperature, wildfires, and there are several repercussions you are already aware of. For example, if you see over here, the use of tropical rainforest timber paneling in the Europe, may result into some kind of a catastrophic event happening in somewhere else, some other country. So you may be aware of this butterfly effect. So the butterfly effect emphasizes the uncertainty and the probability, the uncertain probability of catastrophic events which may occur even from a slightest of change in the ecological balance. So this puts up this important actually emphasis over here to control the actually causes so that the effects can be actually reduced, so the bad effects can be actually taken care of. So Amazon is facing deforestation in the recent times, and there are consequential, not just the environmental impacts, but there are impacts on the society also, like the people who used to live on these forests, people who used to survive with the help of these forests. Traditionally they have been living there for like hundreds and thousands of years. Now they are actually forced to move out, or they are forced to actually take up some other sorts of like occupation practices and their livelihood. So this is not just the environmental impact. Such kind of activities had other like a social as well as economical impacts for the overall like a well-being of this planet. So it is very difficult to comprehend and substantiate than more immediate cause and effect relationships, such as that between car use and the increased pollution. So well, there are some direct actually cause and effect things also, like as it is mentioned over here, like a car which emits like poisonous and toxic gases. But there are some other like a subtle and hidden like a cause and effects phenomena also, which we are observing, which we have just explained right now, this butterfly effect, etc. So these are the ones which have actually very uncertain kind of like a catastrophic resultants over a long period of time. The impacts associated with materials can be remote with regard to both location and time, and they can actually happen anywhere. So for example, if there is like a lot of mining of some metal or some material at one place, may result into imbalance in the like a water level, imbalance in the like a biodiversity of that area, and may result into some kind of like a other like a unnatural like activity somewhere else. So that actually uncertainty is always over there. There are some examples of like the timber might be used like thousands of kilometers from where the deforestation occurs, and then the detrimental effect of asbestos on health only becomes apparent decades of the contamination takes place. So we are all aware of asbestos and some other types of materials which are like conventionally have been like a part of the construction sector. Okay, they are found to be one of the like carcinogens. So, and their impact actually one feels after a longer period of time, and that impact actually becomes like irreversible and quite damaging. So each and every material needs to be like studied properly and should be actually understood to have like a lesser impacts actually, then only should be approved for like uses in the design and construction sector. The resourcing of the materials, their manufacturing processes, transport requirements, use and final disposition can involve wide-reaching environmental and social damage, including like a global warming, which is very obvious and universal, pollution, depletion of natural resources, destruction of natural habitats, extinction of plant and animal species, waste production, destruction of communities, and health problems. So these all of the in the recent like years, this all of these have actually coming to actually the places around us, whether from wherever we belong to, whichever state, whichever country, these kind of like impacts are actually touching on each one's like life in some way or the other. To assess these impacts, material specifiers must consider the chain reaction and long-term effects of using any material, even those that may appear unlikely to be associated with negative environmental impact. So it is very important to understand actually the life cycle analysis of any such material which we are using in like our industry. So material resourcing, about this, building products are derived from like natural materials usually, and that are like harvested or extracted and then processed. So the moment actually processing, the moment actually this manufacturing gets involved, like a factory based manufacturing, the products actually these resources actually they come to possess a different like a kind of a properties also, which may affect our like health and the health of the ecosystem in multiple ways. So the first issue to consider is the availability of the like a material resource. The risk being that resources may become depleted. This is a very obvious fact, and leaving future generations without that particular resource, and therefore at a disadvantage. Like several actually such resources are like so fast like harvested, they are being actually extracted from the like a nature, that it is speculated that some resources may actually go completely actually exhausted from the face of the like a planet. Increased concern about the environmental impacts of mining and resources extraction has resulted in some improvements in these practices. Increasing number of forests are being managed sustainably, and there is a move towards small scale mining in preference to large scale. However, there is still scope for improvement, and by taking these issues into account when specifying materials, consumers can help push the market to adopt ever more sustainable practices. So this awareness actually very important to spread between the manufacturers, miners, consumers, every stakeholder. Well, what sorts of manufacturing processes we can go for? Well, materials are rarely used in their completely natural states. This is what we have seen. Like this is where actually all of this new age actually these manufacturing and fabrication and like an industrialized way of actually treating materials has come into the picture. Some preparation or manufacturing is generally necessary to create a usable building product. The impact associated with manufacturing can include pollution to air, water, and ground, and so on. Manufacturing also generally requires energy, which is mainly derived from like a fossil fuels and is associated with global warming and pollution. So we can see like at any stage of like a products like a life cycle, there are impacts of like a some way or the other. And usually in like today's like a time that the point is highlighted over here in the first line. If you see, like we are not using the materials in their like a almost like a natural or near to natural state. We are actually processing them, we are actually turning them into some other type of like a final product, and then we are using it. And this process itself, it has become quite detrimental to the like ecological balance. At one end of the environmental impact scale, there are like a natural materials. These are materials that are found in nature, such as like a timber and stone, etc., and that require minimal processing before use. A material with such minimal manufacturing impact is the adobe brick, for example, made with earth and water and dried in the sun. A process that makes use of like a plentiful naturally occurring material, uses like a manual labor and the sun's heat rather than burning fossil fuels, and consequently produces like almost no pollution or waste. So like we have seen like adobe houses. So adobe houses are the best example of utilizing natural resources without actually processing them. So whatever processes are actually adopted, those are also very natural. So the adobe actually material is taken, then it is purified, then it is like laid into like a molds, then it is like a sun dried, then it is put together with the mud itself and dried in the sun only. So it doesn't use actually any external or like a artificial energy. It doesn't utilizes any like a industrial processing. Okay, so this is one of the best examples of going with the purity of the material which is abundantly available in the nature. Well, for like a sustainable like material selection, there could be some criteria and some strategies, like minimizing the first of all the need of the material itself, so that we can get rid of the processing and every like other consequences which may arise later on. So building only when it is like a really necessary. Building like small, not very big, because with the bigger volume of the building, bigger size of the building, a huge amount of volume of the material will also be utilized. Design for like effective use of the materials, design for durability and for reduced maintenance. Okay, secondly, we can go for the this grouping of like using existing materials, so that we can increase the longevity, we can reduce the production of the new material if we can if the old material is good enough to be used in the place of the like a new materials itself. So we can go for the reusing the existing materials, we can go for the like reusing existing building components, we can use like recycled materials. So these are actually some approaches, some strategies through which we can take up our like a design exercises. There are some other strategies also through which we can design our like buildings, such as design to enable like a future buildings and materials reuse and recycling. So the designing itself should happen in such a way so at the end of the like a life cycle stage, the building and its components can go for like a reusing and recyclability like easily. They do not actually should pose like a complexity in like a dismantling or like a taking the components out. Design for flexibility and desirability to maximize the building life. So there should be like a flexibility given in the building, in the like a design of the building, so that it can be used with the multi-purpose like application, and the adaptation of that building should be like a kept flexible, so that it can be used for a longer period of time and can in turn actually give its return in terms of like a usability, increased usability. Design for durability, so that it can sustain for like a longer period of time, it can keep serving for a longer period of time. And designing for like a desirability, of course it should be appealing, it should be usable for the like a user. designing for like recycling and to enable the biodegrading of the material. So the material also should be like taken care of in such a way so that they can go for the recycling, and if not, they should be able to degrade on their own naturally without actually intervention from the several like agencies, without for the need of again a further extension at the end of their life cycle stage. Well, there could be some thought processes given for like a material selection by specifying renewable material with the short generation cycle regeneration cycles, specifying timber from like a managed and accredited sources only, for example like FSC accreditation, managed forest actually systems and all. The countries of Canada and New Zealand have actually this kind of mechanism in place right now, so we can learn from these places and we can evolve actually similar practices in our own country as well. We can specify for like a plentiful resources and avoid scarce resources, specifying like materials mined, harvested or extracted with, we can go for like a minimal impact on the local and global environment. We can go for specifying material associated with low manufacturing pollution, specifying materials associated with low levels of CO2 emissions over the life of the building, considering their impact on saving running energy. Consider manufacturers' environmental policies, track records and reporting. Specify materials that do not pollute the indoor air. Select locally produced materials requiring like a minimal transport. So that we were talking about the other day about indirect emissions. So indirect emissions, for that actually transportation sector is one of the major contributions for the indirect emissions, and one material should not be actually taken very far away from the place of its manufacturing or fabrication in order to avoid the indirect emissions. So this is what actually is talking about over in this particular slide. Material disposal and waste minimization. So about this thought, if we see segregating actually the components of the building, and converting them into a inert materials, so that they can actually go with the any other a component, any other a material also. So segregating like a timber, inert metal and soil waste during construction and demolition, and ensure their recycling. Arranging for excess materials ordered, and where possible waste materials to be taken back by the material suppliers, including recycling provisions in the building. So if you see this second point, it talks about creating a mechanism where the surplus material, where the waste, if it can be taken by the supplier from the manufacturing agency, so that they can take it into their as a raw material, and they can again make it as and convert them into the usable product. So this we saw yesterday, in the previous one of the previous lectures, where that carpet manufacturing company was usually utilizing the 100% of its material and for a reuse and for recycling, and they are actually working for creating almost a nil waste from their manufacturing facility. So this kind of efforts are actually laudable, and these are the actually critical strategies which are actually required in today's context. So material, energy and transport, on this thing, if you see, there are some concerns on these factors also. So unlike the example of adobe construction given earlier, most building materials require energy for extraction and manufacturing. Energy is also required for transporting material to the site, maintaining it, finally disposing of it. The total energy used is known as the embodied energy. You have already known this fact. Embodied energy is the energy which is required for a sourcing, for manufacturing, transporting and finishing that product. So that all of these stages actually, if you combine, so the energy required at all of these stages combined in a combined manner is called as the embodied energy. So by reducing energy expenses on each of these stages, we can overall, in the sense, we can reduce the embodied energy of any product. So the total energy used is known as embodied energy. Energy is still mainly produced by burning fossil fuels and is therefore associated with global warming and pollution. Specifying low embodied energy materials is therefore generally desirable. Unfortunately, estimates for the embodied energy of materials can vary depending upon the method used to calculate it, and can be misleading. Embodied energy calculations do not generally differentiate between energy produced with the fossil fuels and that produced by alternative means not associated with CO2 emissions. They sometimes include the energy for the transport of material to site for their maintenance and disposal, and sometimes they do not. Well, so we have to be cautious while calculating actually embodied energy. This is what being talked about over here. This actually doesn't considers whether the energy used in this actually manufacturing of this product, whether it was like a source from like a non-renewable sources or renewable resources, or whether it has actually included some energy which was used while transporting it back for the recycling and all that. So these are actually minute details which we can actually take care of, but it requires actually attention case to case basis. But in an overall sense, actually energy is energy, and whether it is coming from like a non-renewable resource or a renewable resource, as long as it is consumed by that particular product in its manufacturing, it constitutes, it gets added in the embodied energy of that product. About materials in use, maintenance of the materials require both energy and materials, and is associated with the similar impacts as the construction of buildings, albeit on a smaller scale. Minimizing requirements for maintenance by designing for durability and longevity helps to reduce the life impacts of the material. Materials can also affect the building users in terms of comfort and health. Materials like disposal. The building industry in the UK is currently responsible for like 70 million tons of like a construction and demolition waste every year, most of which is sent to like landfills. There are numerous problems associated with landfill sites, including the use of the land, toxic like materials leaching into groundwater, emissions of explosive gases. Sometimes explosions also happen on these like locations, and structural like instability, of course. Appropriate site waste segregation, designing to enable reuse and recycling, and using reclaimed and recycled materials all contribute to diverting waste from landfill and other polluting waste disposal options. Building design can also encourage recycling of domestic or commercial waste by providing appropriate recycling facilities in the building. Building design can also encourage recycling of domestic or commercial waste by providing appropriate recycling facilities in the building itself. Well, another actually strategy over here is like for designing for like a longevity. Well, what is longevity? Longevity means like if we can expand the actually lifespan of any product. So if we are expanding the lifespan of any product for like for example twice, so that directly means we are saving at least production of another unit of that same material by extending the lifespan of the first material in its place. So by using the material for like a twice of its like lifespan, we can at least save on the one unit of that material. Is as simple as that. So the production of new materials is inevitably linked to environmental and social impacts. To minimize the need of new materials, it is important to make maximum use of the material already in existence. Furthermore, making use of existing materials which would otherwise have entered the waste system reduces the impacts associated with waste disposal. So there are only benefits. There is no harm of actually using this strategy like a design for longevity. Some guidance for like designing to enable like dismantling, so this is also one of the very important stages where once the product life cycle is over of like for any product, so it goes for like some sort of like a dismantling, some sort of like a degradation, decomposition, or some kind of like a disposal. So at that time the material or that component should be able to be like get disassembled properly, so that it can be like disposed of, the different materials can be disposed of in a responsible way. So for example, like the some things which are necessary to be like be aware of at the beginning only, like the information. So providing as like a build drawings and a maintenance log, including identification of point of like a disassembly, components and materials. Also identify materials and points of disassembly on like elements. So how that product, how the components of that product are going to be disassembled. So this information should be given beforehand for the like a dismantling agency. About access, provide easy and safe access to the building elements and fixing with minimal machinery requirements, so that they can be carried out without much hindrance. Dismantling process, well, simplifying fixing systems, enabling like removal by means of small hand tools and handheld electrical tools, avoiding a specialist plant, use of like a mechanical rather than chemical fixing, providing realistic tolerances for like assembly and disassembly, designing joints and components to withstand like a dismantling process. And further coming down to the hazard, because hazard is one of the after effects of like this dismantling and actually disposal stage. So how does the hazards can be actually reduced at this stage? So make components suitable for like a safe handling and provide means of handling and locating. Avoid like toxic materials also, because this could be like a harmful for the people who are involved at this actually work. For like a time factor, minimizing the number of parts, fixing and types of fixings, allow for like a parallel disassembly of different building elements, so that there is a flexibility in terms of like the uses, in terms of like a dismantling, in terms of like a recycling, etc. Finally, like guidance for designing to enable the reuse of building elements, and alternatively their recycling if reuse is not possible. Recommends like these following like points. For example, like reprocessing. So use materials that require minimal reworking. Avoid non-recyclable materials such as like a composite materials. They are very difficult to get like recycled. Treatments and secondary finishes that complicate reprocessing, such as like a powder coating, such as like a lamination. So these actually are the and appealing and aesthetical actually treatments and finishing for like a several types of products, but in turn they end up actually complicating that product for its like a disassembly and recycling. So minimize the actually number of component types. Ensure that inseparable sub-assemblies are from the same material, and that components of different materials are easy to separate. For like hazards, minimize toxic content. If toxic content is like unavoidable, ensure the ability to release it in a controlled manner. Make components sized and of a weight to suit the means of the handling, and provide means of handling and locating it. About durability, use sturdy and avoid like fragile materials. Design joints and components to withstand actually repeated use, so that there is no wear and tear so often, and one can save on the maintenance and operations part of the life stage of that product. About information, provide identification of like a material and component types. Provide like product details and installation instructions. So the information has to be complete from like a end to end, to enable actually a successful and unhindered actually operation, as well as successful and complete recycling and disposal of the like any like a building material. So that is actually intent of this actually lecture over here. So we can talk about as a, like a final some like approaches to dispose of like these materials by utilizing actually reusing them, by recycling them, or even like a downcycling them. So reuse actually putting to new use a previously used building component taken from a building or the other source. The building component can be made of a single material such as like a brick, slate tile, timber joist, precast concrete floor, etc., or more than one material such as like a door with like a ironmongery, composite wall panels, precast concrete foundations. So it can require no processing, or for example like a roof tile also, or significant processing, or like a paint stripping and finishing doors, etc. Second, like recycling. So reprocessing a material or component to form the same or an equivalent material or component, such as like a metal roofing recycled to make like a new metal roofing or wall cladding, etc. So they can go for like a recycling or reusing them. And then lastly, like a downcycling, reprocessing a material into a lower grade used material, such as like a concrete or brick into like a hardcore timber, or timber into like a chipboards. So these materials can be like actually downcycled, can actually become inferior, but still can be used into like some other sorts of like usages and applications. So that is the downcycling. So these are the actually strategies which are very important as far as like sustainable building construction materials are concerned, and that is why we have discussed over here. And with this I would like to come to an end of this lecture. Thank you all.